All right, what we have here is Unit 5 Review B. This should be the very final assignment from Unit 5. So we will be taking the test here real quickly if we haven't done so already. And this is just one more review. So get your formula sheets ready. And here we go. So we have these just basic probabilities. We just see what we have and what we don't have. So a sample of 240 lottery tickets, so that's 240 total. And we showed that 39 were some type of winner. All right, so right now, what I can imply is that there are 201 that are not winners. All right, let's see what we have to get a probability of. And your estimate, what is the probability that a lottery ticket will be a winner? So that's 39 out of the 240. Oh, 39 out of 240. 165. 8375. What is the estimate that the probability will not be a winner? So not winners, there's 201 of those. All right, either a lottery ticket is a winner or not a winner. What is the sample space? And what do the probabilities assigned to the sample space add up to? So the sample space are the words. And so that is a winner or not a winner. All right, so that is the sample space. What do the probabilities assigned to those sample spaces add up to? So the sample space are the words, and then what do they add up to? So you can't have one without the other. Here we go. Jar contains half balls and 2 red, 4 green, 3 blue. Again, that's 9 total. First one is with replacement. The second one is not with replacement, and they are and then questions. So that means a multiplication of a blue, of a blue and then a green, a blue and then a green. So with replacement, the blue is 3 out of 9. So again, what that would be is that would temporarily bump that down to 2 and 8. But then I put it back. Then I put that back, making it 3 and 9 again. And so now on the green, that would be 4 out of 9. So now without replacement, I select the blue, which is 3 out of 9, which bumps that down to 2 and 8. And I don't put it back, so those numbers stay adjusted. And now the second ball is a green, which is now a 4 out of 8. Try that one more time. Coach Mannix again. Here we go. The bottom line is, what is the probability of basketball player and an A? Basketball player and an A. So probability of a basketball player and an A. And so this will be found one of 2 different ways. It's the probability of B times the probability of A given B, given B, or it's going to be the probability of A times the probability of B. going to be one of those two. So let's see what we're provided with. So we got the probability of having an A, probability of being a basketball player, probability that you have an A given that you're a basketball player, or the probability that you are a basketball player given that you have an A. So again, what these second terms refer to is the population. From whom are you looking from? Okay, that will kind of help you identify which one it is, because they'll sound kind of tricky. Here we go. 4% of the students are basketball players. So that's straight up being a basketball player. 16% of the basketball players, so that's your population. So 16% of the basketball players have an A. So your population is basketball players, and from those basketball players, we see that 16% have an A. So the things that we have no information about is straight up the A and the B given A. So we don't have any information about those two pieces. So the formula that we're using is logical deduction, pretty easy. Again, how to operate with this E answer. So if you take a look at my calculator, it says 6.4 E to the negative 3. That means I am going to move my decimal place 3 places. And the negative means it's going to get smaller, not bigger. So smaller by 3 decimal movements. 1, 2, 3. So that's 0.0064. Next, we have table problems. Table problems are easy peasy lemon squeezy. All right, so we got liberal arts, 90. We have and, so business and B, 56. Next, we have given. So the second piece is engineering. So engineering is 44. Intersection is the numerator. That intersects with D at 7. Last but not least, we have another given. So the second piece is a D, which is 70. And the intersection with engineering is the numerator, and that's at 7. On to the cards problem. Ooh, we have an and then problem. Oh, cool. I like this. All right, or. Or implies you add the two things up and you subtract off any intersection that you have. That's out of the total. And again, don't forget that the word and then implies you take the probability of A and then the probability of B, whatever those individual probabilities happen to be at the time. So it'll be probably an adjustment. It'll be a given, but we'll cross that bridge when we're there. All right, question A is a red queen or a 10 minus any intersections out of 52. Next one is an 8 or a club minus any intersections out of 52. And then here comes the and then. It's a diamond. Okay, now with this diamond, okay, okay, the first is replaced. So a lot of people sweat that. Okay, so the first is replaced. So that would mean that the card is put back. Okay, because if it was not put back, that would bump down to 12, and this would be 51 if it were not replaced. Okay, but because it is replaced, then it goes back to 13 and 52. Okay, diamond and then a heart. So a heart. Roll a law of large numbers. What are we talking about? A die? There you go. Don't overthink. Draw a tree diagram. 3 entrees, 3 sides, 2 drinks. So 3 entrees, 3 sides, 2 drinks. 18 total. All right, so there's 18 total. The last option is drinks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Ooh, I did fit it in. All right, and so there's 2 of those. All right, families of 2. So the final destination here. The topic before that is sides. There are 3 of those. And before that, we have entrees. There are 3 of those. Nope. George has 7 ties, 4 shirts, and 3 pair of pants. If I'm choosing one of each, that is what, 84? All right, so PE has running a race. There are 16 people. A podium has 3. Does the order matter? Yes, because I want to be first. First is being different than being second. So heck yeah, order matters. There's a president in this. So this is a permutation. The order does matter. There's a precedent. And so that would be 16 permute 3,360 different ways that could be arranged. Here's our take-home exam problem. So there's 8 questions, pick 3. Does it matter the order in which you do the 3 problems? No, doing problems 1, 7, and 8 is the same thing as doing 7, 8, and 1. Okay, so the order does not matter. That is a combo. That'd be 8 combo 3. So 8 combo 3 is 6. That's the ball game. Wow, that was an easy test. Give me my A.